Hi, today's lecture is going to be on loops and debugging. We're actually going to do it as 2 videos, but this will be the topics we cover tonight. So loops and debugging. Our agenda is, first we'll talk about loops. There's two major kind of loops, the while loop and the for loop. And then we'll talk about the break and continue keywords inside of those loops. And then in the next video, we'll talk about debugging. So we'll talk about tools for debugging, how to interpret different error messages that you're going to get, debugging a failing test, and then using the debugger keyword, which I think is the power tool of learning code as fast as you can. All right, so let's start with a while loop. A while loop requires 3 elements: the while keyword itself, a conditional expression that evaluates to a Boolean value, and then a block of code. So here we have something like a while conditional, the block of code, and then the end of the block, which is the end of the curly brace. So here you see the while keyword, the conditional expression. This is going to evaluate to true or false, exactly like the if statement, and then the block of code in between the curly braces. All right, so this block of code will run over and over as long as the conditional expression evaluates to true. So let's do an example. Let count equals 3. While count is greater than or equal to 1, we'll say console log count is count, and then count minus minus, and then close the while loop. So what's happening here is that we assign a variable count to 3, and then when the while loop says while the count is greater than or equal to 1, in which case this count is, you can think of this almost reading as we're talking about earlier with the if statements, right? So it says if the count is greater than or equal to 1, then that's true. So what we're going to do is run this loop, right? And so we'll say, okay, well, console log count is count, which will be 3 right now. Then we decrement count, which means we just set count equal to 2. And then we go back, instead of ending this block like the if statement would, we go back and say, well, while that statement is still true, we still got to be doing the stuff in this block, right? So while the expression on line 3 is true, keep running the code on line 4 and line 5. So here we should expect to see count is 3, and then we'll see count is 2, and then we'll see count is 1. And then what happens after count runs being 1 is that we say count is 1, and then we say count minus minus, that will set count to 0. And then we go back to line 3 and say, well, is 0 greater than or equal to 1? And the answer there is no. And so then we jump to line 7, right? We jump past the while loop. So here we get count is 3, count is 2, and count is 1. So here we go while false. Console log, this line of code will never run. Close that brace. So here, because the conditional expression evaluates to false, this while loop never does anything, right? So we jump right from line 1 to line 4. All right, now while true, this is dangerous because this line of code is going to run forever. So what happens here is that console log, this line will run forever, prints out, and it goes right back to line 1, and that true will always value to true. So your screen will show something like this, and eventually either the computer is going to error out, or you're going to see, what you're going to start hearing is, if you're working on a local laptop, is your fan starts spinning up and your computer starts slowing down, and basically this while loop is occupying as much of the machine as your computer is going to give it to your program. So here we say let count equal to 3. We have to make sure that the conditional will eventually become false, right? Not necessarily in any specific amount of time, but if your conditional never becomes false, then the program is invalid in some way, right? And so while count is greater than or equal to 1, we console log count. This, we have an error because the count always stays 3, right? So this is the exact same error we had in the previous while example, that the count never runs out. So that's why in the previous example, before that one, we have the count minus minus, right? So in every loop, you have to approach what would make the while loop false, right? And so in this one, if we don't do the decrement, count never gets close to being greater than or equal to, or that count greater than or equal to 1 never approaches being false, right? So just be careful when you're using while loops that it's inside the loop, something is happening that is making the while loop eventually false. Next, we have something called a for loop. A for loop requires 3 elements, right? We have the for keyword, we have 3 optional expressions inside of the for loop, and we have a block of code that is run. So for loops look like this. There's a for keyword, then there's an initialization expression, a condition, and a final expression. So here we'll have a block of code, and then that ends the for loop. So this block of code will run over and over until the condition the thing in between the two semicolons evaluates to false. Now, oftentimes beginners struggle a bit with for loops. I don't know if this is because we oftentimes don't use that semantically in English as much, right? We don't say, for all of these things, do this thing until this happens. We'll say, oftentimes because the condition is obvious to humans, so we don't have to necessarily explicitly make it out. But the for loop is just another way of saying almost exactly what we did the while loop, and I'll talk about an example why the two are equivalent to each other. So anything you can do with a for loop, you can do with a while loop, and vice versa. It's just really kind of however you want to express yourself in the code. And oftentimes for loops are just a little bit clearer and a little bit more concise what is happening, because you're capturing the three more important parts of the loop all inside that single line on line 6. You know how we talked about in while loops, if you forget to put the thing that gets the while loop closer to being false, you have an error, right? Your code runs forever. So that's why the final expression on line 6 is usually something that helps the for loop get closer to ending. So the final expression you're oftentimes seeing is, decrementing the count, or increasing a pointer into some array, or something that makes the for loop closer to being finished. So in a for loop, the initialization is run first and only once. It's often used to define a counter variable. Then before every time the for loop iterates, that condition is checked to see if it's true. So if it is, the for loop will run that iteration. Then after the iteration, the final expression will run. So it's not final in the sense that it only runs at the end of the for loop being valid. It runs at the end of every iteration of that loop. So here, what this is saying is the initialization here is letting I equal to 1. Right, that will only run one time when the for loop first starts running. Then the condition is checking this I, is it I less than or equal to 3? And then, in this first case it is, and so it will run. And then after this runs, it will increment I by 1. So here, we should see something like I is 1. And then at the end of, after line 10, you can think of what the code is doing is really inserting something like I++ between line 10 and 11. And then it goes back and says, well, this is I, what I is now 2, less than or equal to 3. It's still true, so now I'll put I is 2. So here we get something like this. I is 1, I is 2, I is 3. Now, after I is 3, we go back and say, well, is I less than or equal to 3? Yes, that's true. Now, at the end of that loop, we say I is incremented to 4. And then we go back and say, well, is 4 less than or equal to 3? And that, of course, is false. And so it jumps to line 12. It jumps out of the for loop and finishes. So one thing that oftentimes beginners get wrong is that they will have a sense that for loops need to follow this certain order, right? They need to increment from 0 up to the length of something, or 1 up to 3. That's not true. For loops, those 3 expressions can do whatever you want with them. And I've seen programs that use them for all kinds of things that are not just iterating through a string or iterating through an array. And so you can loop in either direction, right? So you can go from 5 greater than, down to 1. Here we get, 5, 4, 3, 2, 1. So you can really do whatever you want inside of a for loop. It's not really that you have to go from 0 up to something or from 1 up to something. You can do whatever you would like to do inside the condition of those, or inside the parameters of those 3 expressions, right? You can, as long as you can express what you want to do as something initializing, something checking every loop, and then something changing as the final expression, then you can express it in the for loop. And also you can increment by any number, so you don't have to increment by 1, you can increment by 100. So if you want to output 100, 200, 300, this might be a loop that you write. So I equal to 100, I less than or equal to 300, I plus equal to 100. So the way I would read this typically is saying, well, in this for loop, start I at 100. Then test if I is less than or equal to 300, and for each loop, increment I by 100. And then inside the loop, console log I is I, right? So here we should get I is 100, I is 200, I is 300. Now, here's a very common early example that you'll see in a lot of exercises is using for loops to iterate through a string, right? So a string we talked about is like a literal kind of Christmas tree light of characters. So you can actually use a for loop to access each individual character in that string. So here, let's set letters equal to A, B, C, D, E, F, G. Now we'll say let I equal to 0, I less than letters.length and I plus plus. Now we'll see this construction quite often. So what this is really doing is, and you'll see this I being used quite often too, right? So what do we mean by I? Well, what's happening here is that we're defining I as an index, right? A placekeeper for where we are inside of the string. So, when set I equals 0, we're saying keep track of where I am, and right now I'm at the 0th character of the string. So I'm at the letter A, right, instead of letters. Then, as long as I is less than letters.length, then do whatever in the loop, and then increment I by 1. Now, the curious thing here is that, so the initialization, starts at the beginning of the string. Now remember that most arrays and most things in programming start at 0. So just like arrays, strings also start at 0. So this is the 0th character. And this I++ should be pretty clear that we're just going one character at a time. Now one thing that's often confuses beginners is I less than letters.length. Now why do we do less than or not less than equal to? And the answer is really because of starting at 0. Letters.length represents the character after G, or not the character after G. It represents whatever space exists after G, right? So we want to go all the way up to really the length minus 1, and that's what this I less than letters.length means. So even sometimes when I'm coding, I have to think about this myself, is that if I want to go through every letter, I say, well, here I have A is 0, B is 1, C is 2, D is 3, E is 4, F is 5, G is 6, right? Now, of course, but the length of this is 7. So when I is 6, I'm actually pointing to the last character. When I is 7, I don't want to do anything because I'm not actually referencing a character, right? I'm referencing something outside of the string itself. So just, that might be something early on you just have to memorize, that you want to go less than the length usually of whatever you want to iterate through. So here we'll say let the current letter equal to letters I. Of course, it's saying get the index, use the index, this letter I, to get the character at this point in the string. Console log it out, and then close the for loop. So here we should see each individual character printed out. All right, let's do a quick example of that, just so we can see. So here I'm in Visual Studio Code, and you can see I'll do something like 4, and Visual Studio even has nice things, so I can do something like I, and it'll automatically output what I want to do, less than, here, I'm going to say, let's do letters, .length, I++. All right, and let's just create letters, so let letters equal to A, B, C, D, E, F, G. And we'll say the current letter equal to letters I, and then console log it out. Now if I save this and run it, I should see A, B, C, D, E, F, G. Now what if I want to do this backwards, right? So I would set I equal to, there's a few different ways to do it, but I can set I equal to letters.length, I greater than 0, I minus minus, and then console log letters I, and save this and run. Okay, now people who are sharp-eyed viewers might notice that there's already an error here, right? The first thing I do is get undefined, and I don't get the letter A, right? Because I made the mistake that I just talked about, where I being letters length doesn't make any sense, right? Because the length is now 7, but the index 7 actually points outside of the character array. So if you want to go backwards, what you have to do is length minus 1, and then I greater than or equal to 0, right? Because we do want, when I is 0, to run the for loop. So here, save it, and you can see this prints out what we expect down the ladder. Now, one other thing I want to talk about is the equivalence of the for loop and the while loop. Now here, this for loop has the initialization. So we'll talk about the init is let I equals letters.length minus 1. The conditional is I is greater than or equal to 0. And the also the final statement is I minus minus, right? Which is the same thing as I equal to I minus 1. For those of you who are still getting used to that operator. Now, in a while loop is we can define the same way. We can say, well, what happens is the init is outside the while loop. Then we have the while, and then the conditional. And then we have the code block. And really, of course, we just have to put the final at the bottom here, right? So what we can do here is just say, let's put the init outside the code block. Let's just create a new index so we don't confuse the two. We'll let j equal to letters.length minus 1. And then while the conditional, what we'll do is j is greater than or equal to 0. We'll copy the code block, right? Because we don't need to really, well, you know what? Let me just retype it out because I have to change j anyway. So let current letter equal to letters j, console log current letter. And then here I have to make sure I do something here, right? If I don't do this, so first we should see this, well, why don't we see what happens here? What we'll see is we'll see the GFEDCBA from the for loop, and then we'll see j equals the last letter, j is equal to 0, that's true. We'll get the current letter, and then we'll console log basically an infinite set of g's, right? So if I run this, okay, I get an infinite set of g's. Now I can always go in here and hit Control-C to try to kill it, and then you have to hit it a few times because your processor is running so quickly. You know what? Maybe we can even show that happening. Let me see. So here the G is running, and you can see up here my CPU is going to start pegging up pretty high. Right? So that shows that one CPU is completely consumed right now with outputting G's to the screen. So definitely something to be watch out for, that if your computer starts, spinning up its fans while you're coding something that you think should be simple, then what you have is probably a unended loop. Right? So here, let me just do that thing where I do j minus minus. Now if I run, I can now hear my fans running. Now if I run this, I just see, you know what, let me put a console log between just. Now you see the while loop and the for loop. They're equivalent structures. They're equivalent ways of controlling flow. And so you don't have to really worry about which one you're going to use. I think as programmers become more comfortable with the for structure, it's just much nicer and much more concise to worry about, because really the key thing is that you don't have to worry about what is the final statement in this loop, right? I guarantee that I know that it's there. All right, let me go back to the slides. Okay. So we just covered a for loop. Okay. So now let's talk about these two keywords to use inside the for loop. This is not, not necessarily integral to using the for loop, but it's two important things to know of how do you control flow into or out of the for loop, right? So the one way we know already is for the for loop conditional statement to become, or the conditional expression to evaluate to false, right? So if I is less than 0, or if I is greater than the length, or whatever you put in that conditional statement, when that becomes false, that's one way to exit the for loop. There's two other ways to kind of control how the for loop works. So the first one we'll talk about is the continue keyword. So the continue keyword will cause a loop to skip to the next iteration, right? So wherever that continue keyword is run, it's going to skip the for loop, the rest of the for loop code, and jump to the next iteration of it. So here, let's start I equal to 1, I less than equal to 5. And then we'll say if I equals to 3, continue. Else, just console log I is I. Right? So usually this continue needs to be inside of an if statement, because you only want it to continue in certain situations, right? If you want to continue all the time, then you probably have is not a for loop. You have just like a one statement you want to run. So here we'll console log I equals to I. And then what we see is that we should expect I equal to 1, I equal to 2, I is 4, and I is 5. Because when I is 3, continue means, you know what, skip the rest of the code inside the for loop block and just go back and start testing the conditional and go to the next loop. Right? So we get I is 1, 2, 4, and 5. The continue keyword also works in while loop, so whatever you can do with the continue keyword, you can do in the while loop as well. So here is a piece of code. Let's kind of look at it and see if we can understand what it's doing. So we're saying count is 5, and while count is greater than or equal to 1. So this should initially this should tip you off right away, right? Count is 5, and we're testing until count is greater than equal. We're saying while count is greater than or equal 1. So what this loop is probably doing is getting count closer to being, less than 1. Because if it didn't, then this loop would never end. So what this is saying, if count mod 2 equal to 0, continue. And what count mod 2 equal to 0 means, it's a programmer's way of saying if count is a even number, right? Because what this says is that if the number that you give me divided by 2 has a remainder equal to 0, then that evaluate to true, right? And then here console log count is count. So here we should expect to see 5, 3, and 1, right? Because when it's 4 divided mod 2, this operator here is mod. 4 mod 2 is 0, and then we'll continue in that case. So here we should see 5, 3, and 1. So here we'll look at the break keyword. This is the other way to control the flow of a loop structure. So the break keyword breaks out of the loop permanently, right? So for example, instead of just continuing to the next iteration, we say, you know what, I'm done with this loop, get me out of here. The break keyword is what you need. So let's say my grade is A. While true, my grade equals plus. My grade plus equals the plus sign. And if my grade.length is equal to 3, break, close the while loop. So this is a fun example, but we're saying that my grade is A, right? So A is a string. And then I'm going to add to my string a plus sign. And then when the length of the string is 3, break out of this while loop. Now you notice that this is a true while true, which we talked about not using, right? Now the only case where you can use a while true is if you explicitly remember to have a break statement that you know you're going to hit, right? And so here we should expect to see this is going to be, let's think it through. So the letter A is length 1. So the if statement doesn't pass, but the first loop we say, okay, my grade is A, then while true, of course, is always going to run. We add the plus to it, so now it's A plus. Now that length is 2, so if that length equals 3, that doesn't pass, so we don't run the break statement. We go back and run the test, while true, of course, it's true. We add another plus statement, so now it's A plus plus, which length is 3, so this is now true, and then this will break out of the while loop and jump to line 11. So we should expect to see A plus plus here. So here, this break keyword also works inside of for loops. So for I equals 10, I greater than or equal to 1, I minus minus. Here we'll do a break at line 7, when I equals 7. And what this is doing, if you can guess, is just saying we're going to output 10, output 9, output 8, and then when I equals 7, we output it because it's the console log is above the break. But then when we get to I equal to 7, the if statement, that value is to true, and then we break, and the break says, you know what, don't pass go, don't collect $200, just go to the end of the for loop, line 9, and keep running the code as before. Whereas continue says, jump to the end of the for loop, but then go back up and run another loop if it makes sense, right? If it's still valid to run loops. Break just says, don't go back up and test, just exit the for loop, right? So here, we'll get 10, 9, 8, and 7. And just one more time, why do we see the 7? Is because the console log runs before the break statement, right? So and if there's code underneath this that also would run, then in that 7 loop, that wouldn't output. So for example, let me do some code examples here. So let's see. Okay, so for let I equals to 10, I greater than or equal to 1, I minus minus, we'll just say console log I is I, and then if I is equal to 7, break. So okay, first let's see what happens if we make this continue, right? Now if I run this, what we should expect to see is that we'll get, actually if we expect to see this, we shouldn't expect to see anything different than just 1 through 10. So let's run this. Save. Okay, here we get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And the reason is that this continue jumps to the end of the for loop, which doesn't make any sense, right? Because it's already at the end of the for loop. So here, if we move this console log down, now we should get something behavior that this continue continues to the end of the for loop, skipping any additional code in here. So here we get something. Now watch carefully. I is 7 here. We skip that 7, right? Because the console log never outputs. And then if we do a break here, we get the same effect, whereas we get 10, 9, and 8 because a break jump past the console log. Of course, if we do it as an example, and we have here, then we get that 7. So the break, it's important where it is inside the loop itself. All right, that's it for loops. The key thing here, let me just recap, is that there's two kinds of loops, the while loop and the for loop, and that they're pretty much equivalent to each other. And when I say that, that means that you can write a loop either way. Now, I think as beginners, maybe the while loop is something that we use more commonly in English, and so people are more comfortable with saying, while this is true, keep doing this. The for loop is more concise, and I think the nice thing about the for loop is that it combines all the things we need for that loop into one line, right? We want to know how the loop initialized, what's the loop checking every run, and what's the loop doing to get closer to the loop ending. Now, we also studied two keywords, the break keyword, which just says when the for loop sees a break, it just jumps outside of the loop. And when the loop sees the continue keyword, it ends that iteration of the loop and then checks if it can run the next loop. All right, in the next video, I'll talk about debugging, and we'll start looking at how we can really think through some of these when we get stuck, what we can do.